Welcome to this new series, Indian Monsoon. We have taken this Indian Monsoon in the geography lecture, and this will be divided into multiple parts. I hope it will be extended till part 3. And please be stick with the video lecture till the end, because if you missed any single part of this lecture, it will be very difficult to understand you the further more explanation related to the Indian monsoon, because Indian monsoon is one of the most complex monsoon in the world. That weather phenomena and all is the most complex one that still we have a confusion, and the further the prediction that is made by the weather forecasting agencies have been proven many times wrong, even in this digital era. In this we have lots of technology. So why this Indian monsoon is so much unpredictable, that we will see in this series. So in this part 1 we have taken the Indian monsoon introduction, where we will tell you that a basic definitions that you want to know, that you have to know basic definitions of the globe, that how the trade winds and all moves, what is the reason behind all the trade moves. So the basic platform we will develop in this introduction lecture, and further after that we will take the reasons behind the formation of Indian monsoon in the next session. So moving ahead with this lecture, how the effect of Coriolis force on earth happens. And now, what is Coriolis force? See, first of all, understand that Coriolis force is not actually a force. That is not something called mass into acceleration. That is not a Coriolis force. It is just a term given to deflection. Coriolis force is the term given to deflection. Now let us suppose that you are in a car. This is a car and this is a road. Okay, and this car is moving in this direction. When you will throw a ball from this car to this here, it will be deflected in the backward direction, right? It will be deflected in the backward direction. And when this car will be moving, and when this will be moving fast, like suppose this is a car and this is a train. Now you throw a ball to this train. Ultimately you will get the ball away, that forward from that your car. So that deflection is nothing but is the Coriolis force that we have done. Coriolis force is nothing but deflection. Then similarly, these methodology, these phenomena occurs on the earth. Why? Because earth rotates. Earth rotates. In which direction earth rotates? West to east. That's why we see sun rising from east to west. So the earth moves in the direction of east to in the west to east. Remember this term first. Earth moves in the direction of west to east. Okay, now we will see in what direction it will move on the earth, like the wind will turn in what direction on the earth. We will see, we will try to understand with this diagram. Okay, so before moving into this diagram, first understand one more thing. If we have high pressure and if we have low pressure, the wind will move from high pressure to the low pressure. Okay, this is one of the term that you have to understand. Why this high pressure and low pressure? Like suppose what happens, low pressure means you have a empty space. This is a empty space, and outside this box we have a filled air filled masses. It means it is at high pressure. Now what will happen? This air will try to fill this empty space. So that is why we are saying that there is a tendency that air moves from high pressure to the low pressure. Okay, this air will try to fill this gap. Ultimately this gap will be filled from where air is moving from high pressure to the low pressure. Now one more thing you have to understand, how this low pressure is formed. What is the reason behind formation of low pressure? Now what happens, let us suppose this is a land, and when sun rays hits the land, what happens? Water droplets or the air present on the ground will become lighter. As we understand in the physics that when you hit the molecules, when you hit any matter, the molecules between present in the matter will try to displace, will try to expand, and ultimately this will happen, this will start to rise above, and this create a formation of doldrum kind of situation, vacant kind of situation. That's why we say that will be create a low pressure. So the reason behind the formation of low pressure will be the hitting of the land. Ultimately we will see low pressure. And high pressure, the reason behind the high pressure will be that not intense hitting of the land. So ultimately we will see high pressure on that region. Okay. Now again one more thing you have to understand, how this low pressure and high pressure happens. Like suppose if you have here high pressure, and let me connect the charger. If you have a high pressure here and if you have a low pressure here, and you again have a high pressure here, now what happens? Air will move above. Okay, it will hit the troposphere, it will hit the troposphere, that it will reach up to the dew point, it will reach to, it will, the air will become cooler, like here air will the warmer, now the air will rise above, it will become cooler. Now when they hit with the troposphere, this air will move into two directions, it will move either into this direction, either into this direction. Okay, and when this air will move, it will ultimately start to raising below, raising down, and ultimately we will see it will hit, it will come into one area and it will drop here. So the air after cooling down on the troposphere and coming on the surface, that surface will be called your high pressure. The low pressure will create rising of the air, and high pressure will create the falling down of the air. Similarly in the right side also we will see this air will be deflected above and this air will go down to the high pressure. And ultimately what will happen, when the air will hit the high pressure land, it will again, the land will deflect this air into two directions, into the direction of this one, into the direction of this one. Ultimately what will happen, you will see a formation of one cycle here. This will call something Hadley cell and Ferrel cell, all those things are present here. So we will explain these things in separate topics, but I am explaining more. This is not related to this one, but I am explaining it here so that you can understand monsoon very clearly. Okay, so this will form one cycle. Similarly, when this high pressure wind will move here, ultimately again a certain area the sun rays will fall and it will again create a low pressure area, and again it will raise above. Okay, again it will raise above, and when it hit the troposphere, again it will move into the two direction, into this direction, and this again you will see this is forming another cycle, this one cycle. So in this way Earth's monsoons, winds and all flows throughout the globe. Now through this diagram I have explained in the basic terms. This is a very basic explanation. I have explained it in very basic terms. If you didn't understand, just go through the video again, you will understand it. Okay, now we will see this part. See, this is zero equator. This is the intense heating of the globe in the normal scenario when the earth sun rays falls directly on the equator. When the earth sun rays falls directly on the equator, here there will be intense low pressure. So that's why these area will receive rainfall throughout the year. That's why you will see evergreen forests are found in these regions. If you have a continent in these regions, you will find evergreen forest. Okay, because they will get rainfall every year. Why rainfall they will get every year? Because there is a ocean is present, and when the sun rays will fall on this land, the water will evaporate, and ultimately in the evening time around 4 p.m. and all, you will get again rainfall in this region. That's why there will be evergreen every time forest will be there. Okay, so this is one concept. Warm air rises, here the low pressure will be created. Okay, now what will happen? See, when the warm air will rise, this warm air will rise, ultimately it will hit the troposphere, correct? So then when it hit the troposphere, it will move into this direction and into this direction. Okay, now again this area is your what? This area is your low pressure. Okay, now this wind will move into this direction, and this will move into this direction. Ultimately this troposphere will start cooling down this air, and again this air will come down here. Because of what? Because of high pressure. High pressure forms due to what? Because of the cooling of those air rises from this 0 degree equator to 30 degree north equator, 30 degree north hemisphere, and it will fall down. Okay, why? Because it will be in respect of that, it will be a high pressure. Ultimately you will get here. Now when it hits this land, when this hit this high pressure air, it will move again into the two direction, into this direction and into this direction. Similar concept will happen into the southern hemisphere. Again, when it went to the troposphere, it will get cooled down, and ultimately it will rise down into the 30 degree south, and this will be your high pressure. And when this wind will hit the land, it will move into the two direction, either in this direction and this in this direction. So this will form your one cycle here in the northern hemisphere, another cycle will be in your southern hemisphere. Similarly, when this wind will move into the southern hemisphere, again you will see a low pressure area here. High pressure will tend to here, then you will see low pressure area. How? Like here again it is comparison with, it is not like that you will compare this low pressure area with this low pressure area. No, the intensity of this low pressure will be very more, because on the equator sun rays will fall directly, but on this area sun rays will fall in a scattered manner, but also there will be a low pressure. Compared with, like this is here in the pole, you will be have high pressure because of that coolness. Sun rays does not reach up here, but sun rays reach in the scattered manner in this 60 degree south. Okay, now again what will happen? Two wind, like when this high pressure is present there, so what I have explained in the first part, wind will move from high pressure to the low pressure. So the wind will move to the high pressure to the low pressure, and again one wind is coming here. So ultimately they will strike together and they will raise above. They will get warmer, the warmer air will rises above, and again when they hit the troposphere, this wind will move in two direction, in this direction and into this direction. Again this will form another cycle, and this will form another one cycle. Similar condition you will see here. When this is moving here, another high pressure wind is coming into this, from polar wind to this 60 degree north, and when this will hit together, they will create a warmer air rises above. The height difference of the troposphere in this part, the height difference, note one thing, the height difference in this part and height difference of the troposphere in this part will be less. It means the air which is rising above in the equator will be more warmer, so the space required to cool down will be more. So that's why the air rising on the equator will get more height. So the troposphere, that is tropopause, for that air will be high, but for the air present at the polar are not much that heat, so they will cool down at a very low height only. So thus they will get the height of the tropopause for this air will be very less, and ultimately this will move into this direction, another will into this direction, and they will form another one cell, and it will form into the another cell. Okay, so in this manner your wind travels on the earth. Okay, like this is the manner in which the wind travels, and this made the circulation of wind throughout the globe. Okay, this made the wind to move throughout the globe. Okay, now we will see how this northeast trade wind and how this southeast trade wind forms. We will pause it here. Okay, so this is the whole scenario. Now one more thing you have to know, that the first number, there are 3 cycles is forming. I will rub it again. There are 3 cycles is forming. One cycle is here. Okay, then another cycle is here, and then another cycle is here. Similarly, we will have one cycle here, then another cycle will be here, and the another cycle will be here. Okay, this make number 1, this make number 2, because the both are identical one, and this make number 3 and number 3. Okay, so the number 1 part will be called your as Hadley cell. This circle will be called your Hadley cell. The second one, this will be called your as Ferrel cell. Okay, and the third one will be called your as Polar cell. Okay, so just remember the things. This may come in your prelims type of optional based type of questions. Okay, now we will understand the main part. Now what happens the Coriolis force on the earth? See, just understand that the speed of this part, like suppose if you are at equator, okay, and earth is moving from which direction? From west to east. Okay, the person standing at the pole will face very less effect of revolving of a earth. Just remember that you are sitting on a bowl and you are here, so for revolving here you will see very less effect, see very less effect of revolving. But a person standing over here on the pole, they will face too much speed. The speed here will be high as compared with the equator. Are you understanding or not? That one more thing again I will explain. The person standing over equator, that earth is revolving in this direction. Just try to figure it out into the 3D way. This earth is revolving, so the person to revolve, like a person just standing here, so the earth is rotating, so after some time this person will be here, after this time person will be here, after some time the person will be here. Okay, it means what? The speed faced by this person on the equator will be normal one as compared with the pole. Why? Like if you are standing on the pole, you are standing it here only, and on this place only you are rotating. Okay, so the speed here is higher as compared with the equator. This will be lower. Okay, so what will happen, as I've explained in the Coriolis example, if you throw a ball from high speed car, if you throw a ball like this is your car, this is car is moving in speed high direction, what will happen, your ball will deflect here. If this car is moving here, if car is moving in this direction, and if you are throwing a ball from this car, you will see your ball will move into this direction. It means the deflection will occur from the source into the right direction. Okay, so same concept occurs here in this on the earth phenomena. How, we will see. Just remember one more thing, the comparison with like this part and this part, this will have a higher speed and this will have a lower speed. Okay, this will have a higher speed and this will have a lower speed. It means what, when you throw a ball, it will move into this direction. Ultimately, again, this southeast trade wind, this will have a higher speed, and when you throw a ball and this is moving, as earth is moving into this direction, then it will move into this direction. The ball will move into this direction. Okay, have you understand? I hope you understand it better. Okay, now similar things you will see here. Okay, okay, so what will happen, we will see this part. See, this is your 30° north and this is your 0° latitude. First, always consider the wind coming, like if the wind is coming from this part, this will be your source and this will be your destination. So what I have seen, this is your high pressure and this is your low pressure. Okay, so wind will move, the car will, like when you throw the ball from high speeding car to the low area, what will happen, your ball will deflect into this direction. Okay, so that's why the wind blowing from the 30° north or the 30° south, it will deflect into this direction, into this direction. Okay, now another thing, now again this is your high pressure and this is your low pressure. Okay, as compared with this part, because why this is high pressure, I have explained it here, I will again explain it here, that in this high pressure the air will rise above, it will go here and it will fall below. Again wind will move here, again this wind will move, come here, and again this air will rise above. Why? Because of low pressure, and again this will turn into this direction, That's why we are saying that this part will be your low pressure and this part will be your high pressure. Now from high speeding car to the low speeding car, you will throw a ball, in which direction it will go? It will go into this direction. Okay, and now again from north to south, again here you will have high pressure and here will have low pressure. Now again the ball will move into this direction. Okay, I hope you have understand it. Okay, so when you, like, the wind will blow from high pressure to the low pressure, so this will be your lower speed and this will be your higher speed. So what will happen, from lower to, like if this car is going and you are on a land, and if you throw a ball, so what will happen, and this car is moving into this direction, what will happen, you have to throw into this one to catch this one, this will deflect into this direction. Okay, so that's why the wind will turn into this direction, and similarly here in the southward terms also the wind will deflect into this direction. And similar case you will see in the polar one also, that again you will see the deflection here into this. This is the higher speed, this will be or a higher speed, this will be a lower speed, and when you throw the ball, the air will deflect into this direction. Okay, so it will be a confusing for you to remember it. The formula to remember this logic is this one, that in the northern hemisphere wind will deflect into right direction, and in the southern hemisphere the wind will deflect into left direction and right direction from the respective of your source of origin. See how? Let us consider this part. Okay, what I have shown, what I have told you, in southern hemisphere wind will deflect in which direction? Into the left direction. Okay, see, and this is the source. Wind will go from here to here. Why wind will go from here to here? Why? Because wind moves from high pressure to the low pressure. Okay, so wind will move into this direction, and in which direction wind will turn? It will turn into the left direction. So the left of this part will be your this direction, so thus the wind will turn into your left direction. Okay, now we will see 30° north. Okay, now again this will be a high pressure and your equator is a low pressure, so the wind will go into from high pressure to the low pressure. Okay, in which direction this wind will turn? It will turn in the northern hemisphere, it will turn into the right direction. So the right direction from this source will be your what? Here, this one. From source, just see from source the right direction is your here. This is your left, this is your right. Like from the source, if you see, this will be your left, this will be your right, so it will deflect into the right direction. Okay, similar, this is your 30° north and this is your 60° north. This 60° north is your what? Low pressure. This 30° north is your what? High pressure. Okay, in which direction it will deflect? It will deflect into right direction. So the source is here, this is your, one second, this is your source, so it will deflect into which direction? Right direction. The right direction will be your here. Similarly, in the southern hemisphere, this is your high pressure and this is your low pressure. In southern hemisphere, in which direction the wind will blow? It will blow into the left direction. So which is, so this is your source, because wind will blow from where? In which direction? High pressure to the low pressure. So wind will blow from high pressure to the low pressure. In which direction it will move? It will move into left direction. So the left direction is your this one. Okay, similarly for the polar wind, this is your low pressure, this is your high pressure. Sorry, this is your low pressure, this is your high pressure. So wind will blow in the southern hemisphere in which direction? Right direction. So right direction. Similarly here into left direction. Okay, so I hope you have understand it. Just remember one more thing, I have explained in detail. No need to remember, no need to go through the diagram in the just example, like in the exam you may confuse. So remember only one thing, in the northern hemisphere the wind will deflect in the direction of right. Okay, and in southern hemisphere wind will deflect in the direction of left. Okay, and ultimately at this left and right from where? From what perspective? From the perspective of source, from where it is originating. Like this is high pressure and this is low pressure, so the wind will originate from where? From high pressure to the low pressure. Okay, first thing we have understand that wind will blow from high pressure to the low pressure. We have got the direction. Now in which direction it will deflect? First we will check in which hemisphere it is. It is in the northern hemisphere. In northern hemisphere where it will deflect? It will deflect into the right direction. So for this source, where it is right, the right will be here. Okay, the right will be here, so the wind will deflect here. Similarly here, this is your high pressure, this is your low pressure, so wind will deflect from, go from where? High pressure to the low pressure. Okay, one thing clear. Now we will see in which direction it will move. Then we have to see in southern hemisphere it will move into the left direction, then thus this wind will deflect into the left direction. Okay, so I hope you understand this deflection of the wind. Now the name that is getting, see, the name that we gave, it gave as per the direction from where it is originating. Okay, see, first we will see between 0 degree to 30 degree south. In this direction, see, the trade wind is moving here in this way. It means it is originating from where? In this direction. Like if we draw a diagram, this is your north, this is your west, this is your east, this is your south, this is your southwest, this is your northeast, this is your northwest, this is your southeast. Okay, see, the wind is blowing from which direction? Southeast. The wind is blowing from which direction? Southeast. Thus it is named as southeast. Here the wind is blowing from which direction? Northeast. See here, this northeast, thus it gave northeast. That's why these two names has been given, northeast and southeast. Now it was given for it westerlies, it is westerlies because it is originating from which direction? West direction. It is originating from which direction? West direction. And for this part, this is polar front, this is polar easterlies, this is polar easterlies. Why easterlies? Because see, it is originating from where? It is originating from east direction. It is originating from where? It is originating from east direction. So just don't take that southeast to here, just take that, just consider this part, that the sake of for remembering it, this westerlies will be here, this westerlies will be here because of western part, and another the name is given for the polar, it is called polar easterlies. Polar easterlies because in the pole side. The keep the definition that I have given here, the logic to understand that why this northeast trade wind and the southeast trade wind is given, the reason behind it is only the direction from which it is originating. Okay, from which it is originating. That's why I've explained in the direction way. For this, just remember westerlies, it is a polar easterlies, it is westerlies, this is a polar easterlies. When you compare, this is coming from west side, it is coming from east side, it is coming from west side, it is coming from east side. That's it. Okay, now this diagram is given for the normal phenomena, normal weather phenomena. Okay, this is given because of the normal weather phenomena. What happens in the summer? I will draw it. What happens in the summer? Earth is tilted from, so the hitting of the earth will be moved upward. The ITCZ will move upward. What is ITCZ? That I have said, that doldrum, intertropical convergence zone. It will explain much more in the environment, in the climate chapter, but here just consider that because of intense heating of the earth due to the sun, we call it as ITCZ zone. Okay, so it will move upward. Okay, now what happens when this will move your upward? Your low pressure will also move upward. Okay, your low pressure will also move upward, and ultimately the direction of the wind will also change. Okay, so the direction of the wind will also change. Your ITCZ will change, your direction wind will also change. So let us suppose this is your 0 degree, this is your 30 degree, and this is your 60 degree. Okay, similarly here it is your 30 degree and here it is your 60 degree. Okay, now what will happen? Your sun will Now at that time, the normal heating condition, the sun was hitting directly at 0 degree. Okay, now the sun will move up to 23.5 degree above. Now your ITCZ will form in 23.5 degree here. Okay, and another 30 degree phenomena, 30 degree, that is at 30 degree we saw high pressure. This 30 degree will shift again above 45 degree, and this 60 degree will shift phenomena, this low pressure 60 degree phenomena will shift on the 65 degree. Okay, now the wind will be like that. Now your wind will be like that. I will draw a better figure once, then you will understand it. This is your earth, this is your 0 degree, this is your 30 degree, this is your 60 degree, this is your 90 degree, this is your 30 degree, this is your 60 degree, and this is your 90 degree. Okay, what I have said, now the sun will raise above till 23.5 degree. Okay, now your ITCZ will move here. Let me draw with another pen. Your ITCZ will form here. Okay, what is this degree? This is 23.5 degree north. Similar condition will happen in south. Okay, when the southern hemisphere will shift. Now the earth is shifting to the northern hemisphere. Okay, now what will happen? The trade will be like that only. Here it will into this direction, into this direction, into this direction, because I will write it again that this will be a high pressure, sorry, this will be your low pressure, this will be your high pressure, this will be your high pressure, this will be your low pressure, but again this will not much of your low pressure, but for this it will be your, that low pressure will be here. Now for this direction, here the high pressure will be shift to your 45 degree. Now on the 45 degree you will see that high pressure, that here if is the 45 degree you will see high pressure. Okay, then on the 65 degree you will see low pressure, and in the 90 degree you will see high pressure. Okay, now the wind will move into this direction. Here this southern part will be a similar one, it will be your same, it will be your same, it will be your same, it will be your same. Now here the direction will change. In which direction? Now wind will blow from in this direction, southwest direction, and this will be your called as southwest trade wind or southwest monsoon. This is responsible for bringing the monsoon in India, this southwest, because here high pressure will be formed. As per the, like if compare with this part it will be low pressure, but here it will high pressure with compare with this part. It is not like that if you compare this is high pressure, this is high pressure. No, for this high pressure this will be a low one, but for this one ITCZ it will be a low, that is high pressure. So the wind will move into this direction. So this will be your southwest trade wind, southwest trade wind. Okay, now again this you will get the same phenomena here, then again this direction and this direction. Okay, you will see the direction of wind in this one. Okay, so that is what, when the deflection happens you will get, when the sun moves, when the sun rays falls, moves on the northern hemisphere, you will see the formation of what? Southwest trade wind, because it you will see this direction. So it is raising from which direction? Southwest direction. That's why we have given southwest trade wind. And when the sun will go to the south direction, you will see northwest that you will see northwest trade wind. Here you have northeast, and when the sun moves to the south you will see northwest trade wind. Okay, so this phenomena occur. This is all about effects of Coriolis force on the earth. I have explained it here in detail. Okay, in detail. For that, if you read any book, it will be difficult for you to understand. If you have any doubt, just go through the video lecture again and again. And further, if you have any doubt, just ping me on my Twitter handle. I will be ready to help you via chat or through call also. Okay, so moving ahead, so this is ITCZ that I have explained in theory. So the ITCZ nothing but that shifting of northward, that we will see southwest trade wind and northwest trade wind. Okay, so ITCZ shift northward, so it is due to the rotation and revolution of the earth. So in northern summer, when the summer occurs in the northern hemisphere, sun moves towards in which direction? Northward. So even ITCZ will move northward, because in the normal condition your ITCZ will be where? ITCZ will be present in the equator. ITCZ means what? Intertropical convergence zone. It means the intense heating of the earth will here, the low pressure will be intense, and ultimately this will create a situation of doldrum. The same thing when the summer shift for the northern hemisphere, the sun rays will fall directly here on the 23/2 degree north. So this ITCZ will shift northward. That is what it is mentioned here. So even ITCZ moves northward, which is a low pressure area, and in the same way, as soon it moves to the northward almost around 23.5 degree, the high pressure area in the southern hemisphere will also move northward. Okay, that in the southern hemisphere, like it is telling on same thing, that in the summer there also it will happen in the same manner, and the high pressure area in the southern hemisphere also move that northward, like this one. This will give your southwest trade wind, and that will be called your pressure gradient force. So due to rotation of the earth, Coriolis force is present. Coriolis force is not a force, it is just a deflection. Remember it, it is not a force, it is a deflection. So due to this northern hemisphere, winds deflect to the right. I have explained, I have given you a trick to remember. In northern hemisphere, winds will deflect in the right, and in the southern hemisphere, winds will deflect to the left. So due to rotation of the earth, Coriolis force is present, and due to this northern hemisphere, winds deflect to right, and in the southern hemisphere, winds will deflect to the left. And usually at equator, revolution is not considered, and high pressure area is 30 to 35 degree and low pressure area at 0 degree. Understand? So usually at equator, revolution is not considered, and high pressure area is at 30 to 35 degree and low pressure at 0 degree. It's the same thing is repeated here. So winds blow from high pressure to the low pressure. So once the wind crossing the equator, the winds has to move into the right direction. Due to this, southeast wind changes its names to the southwest trade wind. I have explained why the southwest trade wind, from where it is originating. On that basis we have given this name is given. So it is called southwest monsoon, and this bring monsoon in India also. So this is the reason why we get Indian monsoon, and the factors responsible for Indian monsoon we will take in the next session. So wind names in the given direction, it is taken in the name of that in which direction it is emerging. I have explained it. Okay, if you haven't understand, just go back to this video lecture and again watch it. You will understand it, you will 100% understand it. And even that, after that, if you have any doubt, just feel free to ping on my Twitter handle. I will be ready to help you either through chat, through WhatsApp, or even on the call. Okay, please like and subscribe. Your subscription is a form of payment for me. If you have any suggestions, if you want any on-demand video lecture, please feel free to ping on my Twitter handle. Thank you.